Okay, have a go at the question to start with 7D, please. So if you follow the ideas up till now, you should be able to do that question there on the board. So take your time and use the hints here on the board. Okay, so I'm assuming you paused the video and you've had a go now. If you haven't, you need to, okay? Please don't just keep going along with me. You should stop and actually have a go at these questions. So, what's the distribution? Well, the distribution is as follows. So remember, this is your N and this is your P number. The hypotheses that the thing is equal to it. You know, you're seeing this every time now. And this one over here, you need to read the question to decide which way around this inequality sign should go. So this again is going to be an upper, this is going to be sort of an upper tail that we look at. Okay. So it means if we use probabilities to find, we're going to be doing something like this. Okay. Because of this inequality sign. Well, the probability that you were meant to look at is for 3 or more extreme. You can find that by 1 takeaway values up to and including 2, which is as follows. Okay, this number here is quite a large number, 32%. There's a 32% probability that the thing happens just by chance. So it's not exceptional, it's not special. It's certainly not less than 5%. In other words, there is insufficient evidence to reject it. So we accept. Yeah, we accept H0. Okay, so we're now getting in the position of people when people say like, oh, what are the chances? Or, you know, oh, these trains are always late. People just say that, blah, blah, blah. You can actually test what people are saying here now. Of course, it's slightly subjective based on your significance level. But these are statements that you can now test. So the final part, and I really do mean the final part, this is a short video, this one, is to talk about two-tailed tests, okay? If we look back here, because of this inequality sign, I said that this is an upper tail test. Upper tail is one tail, isn't it? Because it's just the high end that you're looking at. Yeah, it's just like this, the upper end. But you can end up with two-tailed tests as well. And we talked a very small amount about these before. Okay, so we're interested now in biases either way. So we're not just interested in this one, we're also interested in this one here. And these statements are put together under this sign. Okay, this sign covers both of these together. The way that we handle this is exactly the same as before. It just becomes two questions. A question about the lower end, a question about the upper end. We need to halve the significance level. That's really the only other change that's worthy of mention. Okay, so if you were told that it's a 5% significance level, you have to halve it to 2.5%. The reason why is what you're doing is you're splitting your 5% a little bit over here and a little bit over here. Okay, that's why you're halving it. So over a long period of time, it's been found that in Enrico's restaurant, the ratio of non-vegetarian to vegetarian meals is 2 to 1. Okay, so sounds like something to do with a third, a probability of a third, maybe a third or 2/3. It depends which thing the test statistic is, doesn't it? In his restaurant, in a random sample of 10 people, that sounds like N, ordering meals, 1 ordered a vegetarian meal. Okay, so 1 ordered a vegetarian, in other words, 9 ordered a non-vegetarian, right? Using a 5% significance level, yeah. Test whether or not the proportion of people eating vegetarian meals is different to that in Enrico's restaurant. Okay, so Enrico's model is 2 to 1. For Manuel's, is it the same? Is it different? Okay, so Manuel's is like a sample that we're comparing to before. So let's think about this. So where do we start? Well, I'm going to reveal this, but we're going to start with our x, tilde, binomial, n, and p, and so on. That's where we're going to start. And the test statistic, you have a choice, really. But for me, because it says here 1 person ordered a vegetarian meal, it makes sense that the test statistic would be the vegetarian meal. I'm interested to see if they are going to do the same. So, yeah. The proportion eating vegetarian meals, so look, they're basing it all around the vegetarian meals. the probability that we have a vegetarian meal, if it's 2 to 1, and this is the vegetarian part, then the probability is a third, isn't it? Let P be the proportion of people that order veg. So again, it's all about vegetarian meals. Yeah. The reason why they've done X, the test statistic, is because of this 1 here. Okay. That's how they've decided, should we look at vegetarian or non-vegetarian? Right. So the null hypothesis is that the probability is a third. This is the bit that's new then. So the alternative hypothesis is that it's not 1/3, because the question says is different. It doesn't make any suggestion of more likely or less likely. It just says is different. So the way to determine this is it's all about the wording of the question. Okay, you have to read the question really, really carefully to know what goes on there. So what do? Well, we were given this number. We were given this number of 1. Okay, so the probability of 1 is quite an extreme value. It's an extreme value down the low end, isn't it? Because if we have 10 people ordering meals and we expect that it's a third, we kind of expect a number like 3. Yeah, we expect a number like 3 to be the vegetarian meals. So because it's 1, that makes me think that the probability that I'm going to look at here, I'm going to look at the low end. So I'm going to look at the probability of 1 or less than 1. It's always 1. It's always the value or a more extreme value. Well, you could here. It seems like they're working these out separately, but you could just use what we talked about with our calculators before. So the probability of up to and including 1, you work this out directly on your calculator, don't you? The lower end, remember, the lower end probabilities are easier to work out than the upper end probabilities. The probability then ends up being 0.1. In other words, what this means is if 10 people are ordering and there's a 1 in 3 chance that they order a vegetarian meal, the probability that 0 or 1 person orders a vegetarian meal, so I just need to plug my laptop in here a second. The probability, let's just plug this in first. The probability that 0 or 1 people order just by chance is 10%. There's a 10% chance that it happens just by chance. Well, that's quite a lot bigger than half our significance level. That's a lot bigger than 2.5%. So when we have the situation, we say, we still accept H0. There's insufficient evidence to reject. Okay? This question, we may well have also, if you're thinking, we may well have examined the top end, but it's the fact that we recorded 1 result which told us that we needed to look at the lower end. Okay, that's why we only looked at the lower end in this case. Some of you might also be thinking, could you answer this question from the non-vegetarian perspective? And the answer is yes, but you would need to change your probability to 2/3, and you would need to change your X value to 9 instead. So you could answer this question the other way around as well. Okay, pause the video, have a go, read this one here, and remember the key points for the two-tailed tests is that the two-tailed test should reveal itself in the wording of the question, and you are required to halve the significance level. Apart from that, the steps are very, very similar to before. Whether you want to find critical regions and compare them that way, or whether you want to just directly find the probabilities. Pause the video, have a go. Okay, so I'm assuming that you've done that. The teacher thinks 20%, so that's that one there. In a school, read it. Whether or not there is evidence that it is different from 20%, that's where this inequality sign is coming from. You probably wouldn't get 2 marks for this anymore, but you get at least a mark for that. Okay, it should also be outlined here, shouldn't it, as well? N, okay, and 0.2. Or you could write this as P. It doesn't matter if you have this one here. So he finds 9 of them. Now, if you expect 20% read this thing, 20% of 20, well, that's 4, isn't it? So if you find out that there's 9, what's your suspicion? your suspicion is that, you're looking at the upper tail. It's the same way. So you're looking at the probability of 9 or more extreme. How can you find that? Well, one way is 1 minus the probability of up to and including 8. And it gives you this really small probability here. What that means is there's a 1% chance, if the probability really is 20%, there's a 1% chance that 9 or more just happen to be reading that comic. So it's pretty unlikely, yeah? It really is pretty unlikely. And because it's less, that would lead for you to reject H0 and accept H1. Notice also that they've got the critical region approach as well. So you could list the values on your calculator, find the first one that the first one that goes over 95%, and then the next value, and that would cause you to say that the critical region is 9 or more. And 9 is in the critical region. What are all the assumptions that we're making? So some of the assumptions are, well, first of all, that it is distributed in a binomial way. I mean, it seems like a fair assumption, but it is an assumption that we have made. Okay. And what else have we got here? So 0 or anything from 9 to 20 makes the test significant. Yeah, I mean, really, it's just this one here. Okay. So it's that our values are based on this model, this binomial model. Okay. That's why we're able to get these probabilities in the first place. Okay, so key steps for two-tailed tests. Think about writing out the distribution first of all, as we always do. Think about your hypotheses, as always. This will be a p equals. If it's a two-tailed, this will be a p is not equal. Okay, probability to find. So, judge most of the questions. You just need to judge. Are you looking at the upper tail or the lower tail? Do your calculation, or sometimes it will be calculations. Yeah, for example, they might get you to do a critical region for the lower end and the upper end as well. We haven't seen that in the slides yet, but there are questions like that. And finally, a conclusion. So remember, if the thing is exceptional and really, really unlikely to happen, if it's less than the probability, then we say that something's going on. Yeah, we reject the null, we accept the alternative.